Understanding loops in that, loops are control flow systems that allow repetitive execution of a block of code. Loops are an essential tool for tasks that require iteration, like processing lists, generating pattern, or automating repetitive action. Let's say for an example, I have an event and I have 10 friends which I want to send an event letter to. Instead of me writing the letter manually, I can automate the process using loop. That provides the following types of loop: for loop, for in loop, while loop, and do while loop. Let's explore each of them with examples. For loop. The for loop is used when the number of iterations is known beforehand. It consists of 3 components: initialization, condition, increment, or decrement, which is also the update. And let's look at the syntax. We make use of the for keyword, and then inside the bracket we have the initialization, whereby we initialize our variable, which we are going to be checking to determine when the code is going to stop. Then we have a condition to check the variable, and then we update the variable. And inside the curly bracket we have our code block, which we want to keep on executing as long as this condition is true. Let's look at a simple example. So to start a for loop, we simply make use of the for keyword, and then remember we initialize our variable. So I'm going to say int I equals to 1 initially. Now let's set our condition. We are going to say I is less than or equals to 5. And why are we doing this? Remember, when I was giving the definition of for loop, I said we use for loop when you know the number of iteration before, and you already know the number of time you want to iterate your block of code. So for this example now, we are only iterating for 5 times. That's why I'm setting my conditions that as long as I is less than 5, keep on looping. So when I becomes equals to 5, the loop stops. And then let's update our variable I plus plus. And then we can have a block of code that we want to keep on executing as long as this condition is true. Now let's have our block of code that we want to execute as long as this condition is true. So for this one, I'm just going to put into our I for every iteration. So we can have iterations. Now this. And then I. Let's add semicolon here. And let's run this. So you can see I have iteration 1, iteration 2 to 5. Now what does this mean? At first we initialize our variable I to be 1, and then we check if we have a condition written which says that I is less than or equals to 5, and then we increment I. And now inside our curly bracket we have our block of code which we want to execute. So initially I is 1, which is also less than 5. So this code will be executed, and that's why we have iteration 1. Then after that, I will be increased and I becomes 2. 2 is still less than 5, and the code will also be executed, and that's why we have iteration 2. Then I is updated to 3, and then we have 3 here, and 3 is still less than 5. The line of code will be executed, and then we have iteration 3, and so on. And then I becomes 6, which is greater than 5. So as a result of that, we break out of the loop. So the moment the value of your I is greater than 5, this loop stops. And that's how for loop works. So when working with loop, always ensure that you have an updated value that will ensure that at a particular time when you reach the exact length of the loop you're trying to work on, the loop breaks out. So let me go through this example again. We initialize the value of I to be 1, and then we set a condition saying that as long as I is less than or equals to 5, continue to do something, and then we update the value of I by incrementing it. So at first the value of I was 1, we continue, but at the point whereby the value of I becomes 6, because this condition is no longer true, it breaks out of the loop. Imagine me setting this to decrement and I run this loop. The loop is going to continue for as long as forever until I maybe shut down my laptop or stop the code, because I will never be greater than 5. It will keep on going down. So we're going to have 0, -1, -2, and like so. But the same way we can work with increment, we can work with decrement. We just need to ensure that we initialize our value here to be maybe at 10, and then we can say as long as I is greater than or equals to 5, keep on. But the moment I becomes 4, it breaks out of the loop. So if I run this now, you can see now I have 10, 9, 8, 7, 6, 5. So the moment I becomes 4, it breaks out of the loop. Now let's talk about the for in loop. The for in loop iterates over elements of a collection, such as a list or set. It is simpler and more readable when dealing with collections. And let's look at the syntax. The first thing is that we have the for keyword, and then we have an element in the collection, and we'll make use of the in keyword, and then we have collection, which represent the list or the set. So this element means an item in the collection, and this collection means the all items in the collection. So what we simply mean is that for each item in a collection, I want to do something. So what we use this to do is that we use this to perform an action on each element in a list or in set. Let's look at an example. So here I have a list of fruits. So I have apple, banana, and cherry in my list of fruits. So I want to loop through this list of fruits. What I can do is I can say for, which is our keyword, and in bracket I can say for fruits. So it's of type string. I can say for fruits, which means each item in our fruit list in fruits. Now let's do something. We can just print each fruit out. And let's run this. So you can see we have apple, banana, and cherry. So what this does is that it iterates over our collection and it performs an action on each item in our list, in our set, or we can say collection as a whole. So that's how the for in loop works. Now let's talk about the while loop. The while loop executes a block of code as long as the given condition is true. This condition is checked before iteration, and this is the syntax. We make use of the while keyword, and inside our bracket we have the condition, and inside our curly bracket we have the code block that we want to execute as long as this condition is true. Let's see a simple example. So let's initialize a variable count equals to 1, which we are going to be checking using our condition. So we can say while count is greater than or equals to 3. And now let's have our block of code. Let's print count, and then we can print count. So yeah, a very important thing you must note is that at the end I must find a way to ensure that at the point this becomes false. And how do we do that? We can say count plus plus. So if you take a look at this is kind of similar to the initial for loop. Just that the way we write this is a bit different. For the for loop, you could remember we make use of for keyword, and then we have initializer at first, which is going to be this here, and then condition, and this increment, and this updates that we have here, we have it here. So but for the while loop, we can initialize our variable anywhere. Whatsoever we want to check our condition against, we can initialize it anywhere, and then boom, But the most important thing is that you must have your condition inside this bracket, and then at the end of your block of code, you must always find a way to ensure that this becomes false. So let's run this code now. And now you can see I have count 1, count 2, and count 3. So what do we have here? We have the while loop keyword, and then we have our condition and our block of code, and then we update the variable which we set before the while loop, so that at the point this becomes false and the loop breaks. Now let's talk about the do while loop. The do while loop executes block of code once before checking the condition. It guarantees at least one execution, unlike in the while loop whereby you check condition first before executing block of code, and which means sometimes you might not even have an execution of code. If initially the condition is false, then you won't enter into the loop. But in the do while loop, you execute the block of code first at least once, and then check for the condition, and then you keep on like that until the conditions become false. So let's see an example. So first, let's initialize a variable. So we can say int count, and let's make our count 1, and now we can have 2, and our block of code print count, and let's have count here as a semicolon. So we make use of the do keyword, and then we have our curly bracket here. Inside the curly bracket we have our block. Inside the curly bracket we have our block of code that we want to execute, and after that we make use of the while keyword, and now we can have our condition here which says count is less than or equals to 3. Now the first thing we do is that, just like I said, we make use of the do keyword, and then inside the curly bracket we have our block of code which is being executed, and after executing this, and then we move down to the condition statement, and then we check if this is true, we'll continue, but when it's false, we break out of the loop. So let's run this. So I made a mistake now. You can see that my count didn't stop. It will keep on running like this for life until maybe I stop my computer or terminate my VS Code, or I terminate the code. And who can tell me the error which I made? So guess, what error did I make? You can drop it in the comments. So the error I made is that I did not update my value. So forever this count is going to be 1. So I need to always ensure that I find a way to make this condition false, or else I will have a infinite loop. Let me update our count, so we can say counts, and let's say plus plus, and now let's stop. So you can see it's still running. So now let's stop our code, and then let's rerun it. So you can see now I have count at 12,395. So that's what happens when you don't find a way to always make your condition false. So let's run this again now. And now you can see I have count 1, count 2, count 3. So always ensure that you find a way to make your count become false, or else you will run into similar error which I just did now. Now let's talk about control statements in loop. We have 2 statements in the control statement in loop, which are the break statement and the continue statement. Let's start with the break statement. So let's say we have a for loop like this, which is I equals to 1, and then I less than or equals to 5, and increment and update I. And then inside this for loop, we have a condition statement which says if I is equals to 3, we want to do something. So we can make use of our break, and then we can say that when I is equals to 3, break out of this loop. And if we run this now, you will see that we have 1 and 2. So initially the value of I is 1. We execute the block of code that we have inside it. That's why we have 1 here, and then we continue I is equals to 2, and then we do the same thing. So we can make use of the break keyword to get out of the loop when a certain condition is being met. So we make use of the if condition statement. We have that when I is equals to 3, break out of the loop. Same way we can break out of the loop, we can also make use of the continue statement. So what this does is that it will make use of the continue keyword here. What happens is that when I is equals to 3, we skip that value and then we continue with the next value. So let's run this. So you can see I have 1, 2, and then when I is equals to 3, we skip 3 and then we continue with 4 and 5. And these are ways we can make use of the control statement. In control statement, we have the break statement and then the continue statement. The break statement terminates the loop immediately, while the continue statement skips the current iteration and proceed to the next one. Now let's talk about nested loop. Nested loop is a loop inside another loop. So when we have a loop inside another loop, we call it nested loop. It is often used to work with multiple dimensional collection. And let's see an example. Let's have a for loop which is int and then I equals to 1. And let's set our condition to be this, and I plus plus. And now inside this for loop, we can have another for loop, and that's just what nested loop is. So we can say another for loop. So the second loop we can have int j equals to 1, and you can say as long as j is greater than or equals to 2, let's have j plus plus. And now let's have a block of code that we want to execute. So we can just print something simple like this. J. And now let's run this code. And now you can see we have I is 1, j is 1, and then I is 1, j is 2, I is 2, j is 1, and like that. So what happened is that, so now let's explain what we have here. So first, I is equals to 1, and then as long as I is less than or equals to 3, execute the block of code that we have inside our loop. Then after that, increment it. So I will be 1 at first, then we'll move inside our loop, and then here we have j to be 1, and as long as j is less than or equals to 2, execute the block of code that we have inside our for loop here and then increment it. So j will be 1, and then we'll execute the block of code. So j is 1 initially, we executed the block of code we have, then we increment it to 2, and j becomes 2, and then we execute the block of code that we have here, and then we print 2 out, and then we update it by incrementing it. J is now 3, which is not less than or equals to 2. Then we break out of this loop, go back into our first loop. J will now be 2, and then we do the same thing. 2 is less than or equals to 3. We have to execute the block of code that we have inside our for loop, which will make j to be 1 again, and then the same thing we did the other time. We do the same thing. Then after that, we'll break out, and then we'll move back to our initial loop. Now j is 3, and then we do the same, and we'll continue like that. So that's how nested loop works. So I hope you understand this. So if you understand, kindly drop in the comment section that well understood. Loops in that provide a flexible way to repeat tasks and work with collection. Each type of loop has its own strength and it's suited for different scenarios. By mastering loops and control statements, you can write efficient, clean, and dynamic task code. Experiment with the examples and implement them in your project. If you enjoyed this tutorial, don't forget to subscribe, like, and share your question in the comment section. See you in the next tutorial.